Hi everyone, I'm Carolyn Douglas. Welcome to UW 360. We're joining you from the Paul Allen Center for Computer Science and Engineering here on the UW Seattle campus. This is one of the top-ranked programs in the country and home to some mind-boggling research involving humans sending brain signals through the internet to control other humans' actions. We'll tell you all about that a little later in the show. We'll also learn about leading-edge research into rebuilding the human heart. Plus, see how UW faculty members are working to protect all of us from the dangers of texting while driving. And learn the inspiring story of a young man addicted to drugs and suffering from a terrible disease who went on to become a nursing student with a global mission. But first, ocean acidification is a major concern for all of us here on planet Earth, and especially for the thousands of people who work in our state's shellfish industry, which is why state legislators dedicated the funding to build the new Washington Ocean Acidification Center at the UW to tackle this issue. As Don Porter with the Applied Physics Lab reports, the center's primary mission is to learn how to better forecast where and when corrosive waters are headed our way and what we can do about it.
The ocean absorbs excess carbon dioxide from the atmosphere. The CO2 causes the seawater to become more acidic, more corrosive. That in turn can damage or kill developing shellfish.
The shellfish industry here in Washington State supports about 3,200 jobs and generates about $270 million in economic activity annually.
Saving the shellfish industry helped to fuel political support for doing something about carbon emissions and acidification. Support at the state level.
We've been very successful with those two offshore buoys.
And in Washington, D.C.
Because it tells the the near-shore growers when ocean acidification events are coming.
To me, this is about information that we now can acquire about the ocean.
In 2013, the Washington legislature appropriated $1.8 million to establish the Washington Ocean Acidification Center at the University of Washington, co-directed by Jan Newton of the Applied Physics Laboratory.
What we will be doing is focusing on the issue of ocean acidification and understanding its impacts, understanding the science behind it, understanding the status in Washington waters and its impacts on biology.
The Ocean Acidification Center at UW is a very exciting development for the industry.
An industry that depends upon salt water.
I would have to do the math here.
A lot of salt water.
Maybe 100,000 gallons.
100,000 gallons a day.
The water that comes from Puget Sound, if it's not right, we're out of business, both from a pollution standpoint, but also, as we've learned in recent years, from a chemistry standpoint.
The new center will work with many partners on and off campus.
We have developed the observing and monitoring locally. So what this center does is allow us to really have that connection right here in the region. That center can actually help us advance that science.
For the industry, I think the highest priority immediately is helping us to learn how to better monitor the water and then how to adapt when we get this corrosive water coming our way, either how we can dodge it or when we can't, how we treat it, how we adapt to it.
We have some real-time buoys in Puget Sound, in Daybob Bay. We are going to be outfitting that with NOAA's PMEL ocean acidification sensors for PCO2 and pH. And these will be in a very robust manner so that those data can be transmitted through NANUS's web portal, through the IUS system, to give people a glimpse of the data in near real time.
Valuable new data to be coordinated and mobilized by the new Washington Ocean Acidification Center.
Ocean acidification is a problem we're going to be living with for generations.
If you'd like more information about that story, just head to our website at uwtv.org/UW360. When we come back, a major breakthrough in learning how to rebuild the human heart as UW360 continues. Welcome back to UW360. Every day, doctors and scientists here at the University of Washington make great strides in medical advancements. and perhaps none greater than Dr. Charles Murry and his team at the UW Center for Cardiovascular Biology and the Institute for Stem Cell and Regenerative Medicine. They're on the leading edge of producing arguably the biggest breakthrough yet and helping rebuild the human heart. UW360's Erin Mayovsky explains.
It's the sound of life for everyone. But for some, a simple heartbeat does not come easy. In the United States, heart failure is epidemic, and the statistics are staggering. The Centers for Disease Control and Prevention say 600,000 Americans will die this year alone from heart disease, and nearly 1 million will have a heart attack. But that's just the beginning problems for survivors.
The heart doesn't grow back new muscle, it grows scar tissue instead. And so the patient who survives their heart attack is left with some kind of deficiency in their pump function afterwards. And unfortunately, it progresses. And so their heart function gets worse and worse and worse over time, and they develop a syndrome that we call heart failure.
Here at the University of Washington, Dr. Charles Murry and his team are developing cutting-edge technology for the human heart. Instead of just treating symptoms like high blood pressure and monitoring blood volume, the incredible physicians are making major strides in heart regeneration, meaning rebuilding the heart through new growth from stem cells. And what you see here, a live human heart muscle repairing itself.
Well, that took us a number of years to master the art of building human heart muscle in a dish, and now we're able to take that muscle and transplant it into the hearts of experimental animals and create beating human heart muscle that sits as a repair tissue in the injured hearts of these experimental animals. And so this is very encouraging to us that this may be a path forward to treating patients who clinically have had heart attacks.
Dr. Murry says nearly 200,000 people in the U.S. alone could benefit from his cutting-edge technology, and that's just the tip of the iceberg. Regenerating heart tissue could help millions in years to come.
Last year, the CDC says the U.S. spent nearly $109 billion in heart-related issues like healthcare, medication, and lost productivity. Murry and his team know how valuable their research and development is worldwide. For them, the heart of the matter is also personal.
I'm passionate about it because I'm a physician, and I see this as a chance to make a contribution to one of the most dreaded diseases that our society is facing. It's personal for me. My mom has heart disease. 2 of my 4 grandparents died of heart disease, and so I've personally seen a lot of pain and suffering caused by heart disease. So I recognize the burden that this places in a family and so forth.
What's very unique about this is it's not a pill, it's not a protein, it's not a typical therapeutic, it's a cell-based therapeutic. Even more so, it's a stem cell-based therapeutic, which makes it very innovative. That field has been very scary for a lot of folks previous to this time, but more and more investigators are working with primarily adult stem cells and showing benefit with those cells.
The whole point is to get to humans. That's the whole point of our Stem Cell Institute. We're very motivated to take new knowledge and put it in service to society in some way that it is actually fundamentally useful. And the best way that I can think of is to make a new therapy out of it.
Murray's team says in the future they won't be able to prevent heart attacks entirely, but for those who do suffer from one, they hope to regenerate the heart back to the way it was.
Erin tells us Dr. Murry believes he and his team are just a few short years away from testing their research on humans. Our next story is about something that bothers us all, and yet so many of us still do it. We're talking about texting and driving. It can be just as dangerous as driving while drunk, and it plays a big role in many collisions. That's why University of Washington faculty are rallying around the problem and applying perspectives from public health and policy and technology to help make a safer tomorrow. UW360's Austin Siedentoff has the story.
What is it about cell phone use or texting that makes it almost a compulsive Pavlovian response? hear the bell, you got to somehow answer the bell. The distraction from the cell phone basically sucks you into another world.
Dr. Beth Ebel is a trauma specialist at Harborview Medical Center. Her work with victims of car collisions has led her to conduct a variety of studies on the dangers associated with distracted driving.
I work every day at the trauma center, and for me, when I'm on service, I'm taking care of injury when it's already happened. So it does get me to focus on, is there something that could have been done to prevent this injury so this person didn't have to be here in the first place?
The results of her most recent study are startling. At any given time, as many as 4% of drivers in Washington are texting.
When you're texting in the car, the study suggests that the risk is equivalent to a 23-fold increased risk of crash, which is equivalent to an alcohol level of 0.19. You could hardly find your car if you had an alcohol level of 0.19.
Dr. Ebel's research has done a lot to show trends among distracted drivers, but looking at it as a public health issue alone will not be enough to solve the problem.
We are going to need better technological solutions. Your phone is smart. And right now it's a little bit outsmarting you. That's the risk.
If I seem distracted, it's because I'm operating a driving simulator here at the School of Industrial Engineering. You see, data from hundreds of these simulations, as well as from actual crashes, have shown that driving while distracted, especially while texting, can be about as debilitating as driving while drunk. And I'm on the wrong side of the road.
And they did it because of that reason, because the steering wheel was in its way.
Dr. Linda Boyle operates a human factors and statistical modeling lab where she is approaching distracted driving from a technological perspective.
Technology is just not going away, so we're not going to be able to just get rid of all these different types of distractions. So our goal from an engineering perspective is to look at how we can actually use technology to help mitigate the effects of technology. For example, we have an eye tracker. One of the things that we can do with the technology is when you're looking off the road for too long. So for example, we can use the eye, like your eye movements, and recognize when you've been looking at the in-vehicle device compared to on the road, and then provide you a warning as to whether or not that you should be now looking back at the road. So we're testing such a system on the road with truck drivers right now.
This kind of creative engineering, combined with education about distraction and enforcement of policy, are the kinds of solutions we need to make roads safer.
I think in the future, one of the things that we really should look at is whether or not we can use technology to help provide better information to drivers. I really do believe that if you tell people what they're doing right and wrong at the moment, that they can actually learn from their mistakes.
Distracted driving, especially in the form of texting, is a modern problem, and it's going to take modern solutions in medicine, technology, and law to solve. Luckily, places like the University of Washington have experts from all of these perspectives collaborating so that we can take the next step forward. So remember, next time you get in the car, know what your risks are. I'm Austin Siedentoff, and I'll see you next time.
Straight ahead, from a horrifying situation to a triumphant survival story, when UW360 continues. Welcome back to UW360. Our next story begins with a homeless young man from Redmond who appeared hopelessly hooked on heroin and other drugs when he then contracted the dreaded flesh-eating bacteria. Near death and in a coma for weeks, he wasn't expected to make it. But thanks to the incredible treatment he received at Harborview Medical Center, he survived. And what he managed to do next is amazing. UW360's Bob Branham has a story you won't soon forget.
Do you guys want to do one all together? We'll have one person volunteer to be the nurse.
Without his nursing scrubs on, Eric Seitz looks out of place next to his fellow students during this instruction at the University of Washington School of Nursing. That's because this first-year nursing student is just observing a class he's not due to take until this fall. Eric is determined to succeed at his student career here.
Kind of the holy grail and one of the schools that people most want to get into is the University of Washington for the reputation that it has as being one of the best nursing schools in the country. Basically, they were going in every day to do the debridement surgeries.
Eric was accepted at other nursing programs, but his decision to choose the University of Washington's lies in his disfigured and badly scarred right leg.
So this is the scar that happened. Basically starts right above the hip.
The result of an infection that left him in a coma and very nearly killed him.
Living in bad environments, not being really clean and hygienic with that behavior, that I ended up getting that infection.
Eric grew up in a loving middle-class family in Redmond, but in his teens and early 20s, he chose the street life in Belltown and here in the back alleys of the University District, homeless, drifting from shelter to shelter, and becoming a drug addict. It was his addiction that led him to inject a contaminated dose of heroin into the muscle of his right leg 5 years ago. He was 24 years old.
I didn't expect to live past the age of 25, so I was completely accepting with that. I didn't really care either way or another, you know.
He arrived at Harborview Medical Center in November of 2008, diagnosed with necrotizing fasciitis, known more commonly and gruesomely as flesh-eating disease.
Well, necrotizing fasciitis or necrotizing soft tissue infection is what Grandpa called gangrene.
Dr. Hugh Foy is a U of W medicine surgeon at Harborview and a specialist in this very deadly disease.
The disease is so dangerous, it will take people's lives sometimes within 24 to 48 hours. And some have described it as talk and die. Somebody will come in talking and they'll suddenly become fulminantly, severely ill and be dead within hours. And I've seen that myself.
Eric arrived talking, but soon lost consciousness as the flesh-eating bacteria raged through his body. Eric spent his 24th birthday in a coma here at Harborview Medical Center. Though he was unaware of them, his family surrounded his bedside, bringing balloons and singing happy birthday. His doctors said he had a 5% chance of survival. But thanks to luck and the skills of his doctors and nurses at Harborview, he did survive. It was due to them, he says, that he determined to turn his life around and become a nurse himself.
So that was kind of a humbling experience for me, and it really showed me to be grateful for a lot of the more simple things in my life.
But if it's a small clot, what they would first want to do is actually just remove that clot.
Now, in addition to pursuing his nursing classes, Eric volunteers at overseas surgical clinics during his summer breaks, most recently in the jungles of Ecuador.
We are basically doing direct surgical care for people for free in the most remote areas of the country and within the jungle. It keeps me in a mentality of helping other people rather than focusing on myself, and it's because I got a lot of my hospital care at Harborview. Ever since then, I've been trying to find ways to repay society.
So they'll go in and they'll literally put in something to rehab.
His goal now is to complete the nursing program at the University of Washington and use those skills to reach out to others who are homeless and addicted, to treat them both physically and emotionally, and to serve as an example of what he had to learn the hard way, that a better life is possible.
My motivations have not really been anywhere other than to really be helpful to other people. And it seems like things have been put in place to allow me to do that.
When we come back, will we soon be able to control another person's actions through the internet? More on a remarkable research project here at the Paul Allen Building as UW360 continues. Welcome back, everyone. What was once the stuff of science fiction is fast becoming reality here at the University of Washington. 2 UW researchers have performed the first reported demonstration of non-invasive human-to-human brain interface, which means one researcher was actually able to send a brain signal through the internet to control the hand motions of a fellow researcher. As you can imagine, this could open up all kinds of possibilities.
The technology for actually interpreting brain signals in real time, rapidly,
is quite new. So this has been happening maybe over the last 10 years or so. And also the fact that there's technology now that can stimulate the brain. Even that is reasonably new technology. And I think what people haven't done before is putting the two together. At Harvard showed that you could record from a human brain and then send that information to the brain of a rat that was anesthetized and then make the tail of the rat move. But what had not been done before was actually one human sending information to another human's brain and the two of them collaborating, cooperating to solve attacks. We found that the technology exists right now to do a simple proof of concept demonstration that you can record from one brain and then stimulate another brain.
I've been working for the past year on modeling how the brain works, and in particular how the brain represents knowledge. And we've been using TMS and functional magnetic imaging to understand and reverse engineering how information is represented in the brain.
From my point of view, I was actually not sure that the technology that we have, this technology called transcranial magnetic stimulation, or TMS, is that really a technology that would allow somebody to transmit information directly into the brain?
Just try to remain calm, focused.
So during the experiment, I'm wearing a cap that looks like this. It kind of looks like a swim cap, but it's a cap for a procedure called electroencephalography. The short form for that is EEG. And this is a very standard technology that people have been using for monitoring sleep patterns. But more recently, people in the field of brain-computer interfacing have been using this for recording brain signals non-invasively, and then using that to control things like a cursor.
Move it a little bit posterior.
On our side, we first map the part of the brain that controls muscle activity, in particular the part of the brain that controls my right hand. And this part is actually on my left part of the head. Then we use this machine to generate electrical fields. This part goes into a big box of electrical equipment that generates really strong electrical currents. The electrical currents flow through this coil and generate an A-shaped figure. This in turn generates two cone-shaped magnetic fields, and at the point in the middle of these two magnetic fields, the magnetic intensity is particularly strong, so strong in fact that it can trigger the activity of the neurons indirectly. And whenever Rajesh was thinking about moving the hand, the computers were controlling this electrical equipment that was generating these magnetic fields through powerful electrical currents, and these were in turn triggering a corresponding movement in my hand.
I really didn't realize what had happened until like a few moments after it had happened, and it was like, holy man, what happened?
It was actually even more difficult for me because I was completely isolated. I couldn't see the screen, I couldn't hear anything. And actually, for the first time, I don't think I even noticed that my hand moved. Because I was like so nervous. But then what gave it away was that everybody in my lab was like cheering up and saying, clapping, and in that moment, I remember I thought like, we did it. In terms of therapeutic and medical applications, we have colossal range of options. But imagine these two possible scenarios. Imagine, for instance, people who have been affected by stroke and they have lost basic functions of their brain that need to be relearned, like moving, walking, swallowing in some cases. We have never tried this, and we don't know if it's possible, but we believe that it would be worth exploring the idea that you can help the recovery process by literally transmitting the motor programs of a healthy brain, of a brain that has recovered from a similar lesion, to the brain that has been damaged. This way speeding up the recovery function. And we can generalize this idea. We call this model the brain tutor and the brain student, which are now connected and can exchange information to any set of possible diseases, including psychological diseases, psychiatric manifestations, symptoms, where you can have two brains paired up and one brain being a healthy brain driving the activity of the disease or malfunctioning brain and slowly reshaping its function in a way that is more functional. It definitely spurs some interest, and lots of people ask and email us for details. So we believe that other people are going to replicate our setup and our funding, which is good. That's the way science works. We do experiments and we make them public because we want people to do it and push forward. It's a collaborative enterprise in the global scale.
All right.
That does it for this edition of UW360 from the Paul Allen Center for Computer Science and Engineering. If you'd like more information on any of the stories you saw today, just head to our website at uwtv.org/UW360. Thank you for watching, and we'll see you next time with all new stories from the University of Washington.